Electron beam incident on a narrow slit. Consider a uniform beam of electrons of momentum p falls at normal incidence on a screen with a narrow slit of which d. The electrons passing through the slit form a spot on a second screen a distance L from the first screen. Assume L is much greater than d. What is the quantum mechanical wavelength lambda associated with the electrons? If d is much greater than lambda, what is the approximately diameter S sub 1 of the spot formed on the second screen? If lambda is much greater than d, what is the approximately diameter S sub 2 of the spot formed on the second screen? What width d sub m will give approximately the minimum diameter S sub min of the spot on the second screen?
Answer. P equals italic h over 2 pi k equals h over 2 pi dot 2 pi over lambda equals h over lambda. Thus, lambda equals h over p from De Broglie. D is much greater than lambda. Have geometric optics diameter image asymptotically equals diameter hole. S sub 1 almost equals d. Lambda is much greater than d. Diffraction important. As lambda over d goes to infinity, we get S sub d goes to infinity. D sub 0 equals the square root of 2L lambda.